What's up, you freaking geniuses? So in this video, I'm going to teach you how to graph polynomial functions and describe their end behavior. All right, so let's start with this one right here. F of x is equal to 1/2 times all these parentheses, right? X plus 4, x plus 8, and x minus 1. All right. Now, in order to graph this, the first thing we need to find are the zeros, or the solutions, or the x-intercepts. Whatever you want to call them, they're all the exact same thing. Okay, and the sets of parentheses that we have tells you how many zeros or solutions or x-intercepts we have. All right, so here we have 3 sets of parentheses, right? So that means we're going to have 3 zeros, 3 solutions. So that means when we graph our polynomial function, it's going to cross the x-axis or touch the x-axis at 3 points. Now, those 3 points you find by just setting each set of parentheses equal to 0, right? So if we set x plus 4 equal to 0, that means the solution for this one would be that x is equal to -4, right? Same thing over here, x would be equal to -8, and here x would be equal to +1. All right, so these are the 3 points that our polynomial function is going to go through. So at x is equal to 1, -8, and -4, right? So we'll plot a point there. We'll say this is 1, we'll say this is -4, and this is -8. Okay, great. Now, what is the graph actually going to look like? So one little helpful tip I want to point out is look at the number of solutions or zeros that we have. We have 3, right? So if we have an even number of solutions, your graph is going to look something like a parabola. Okay, and if you have an odd number of solutions or zeros, like we do here, right, we have 3, then your graph is going to look something like, not exactly necessarily, but something like a cubic function. Okay, now why am I saying it'll look something like a parabola or something like a cubic? Well, if we had only 2 solutions here, or 4 solutions, or 6 solutions, then again, it would look something like a parabola, but it could have this weird little blip in the middle, okay? Or it could be upside down, right? It could look something like that. But in any case, you can see it basically resembles a parabola, right? So again, that's when you have an even number of solutions. Now, when you have an odd number of solutions, it's going to look something like a cubic function like that. But just with like the parabola, right? If you have 3 solutions or 5 solutions or 7 solutions, it could have like a weird blip like that in the middle. Okay, and same thing if it were sloping down, you know, still the same thing. You can see it still looks like a cubic, but again, just has that weird blip in the middle. Okay, but in any case, we have 3 solutions here, so we know it's going to look something like a cubic, right? Now, is it going to slope in the positive direction like that, or is it going to slope down like that? Well, to be able to tell that, you just have to look at your leading coefficient here, which is a +1/2, right? Now, if this number is positive, it slopes up. If this number is negative, then it slopes down. So here it's positive, so that means our graph is going to look something like that, okay? So we know over here on this end, it's going to be sloping up like that, and on this end, it's going to be sloping down like that. And now it's basically just plain connect the dots with these 3 guys right here. Okay, so we're going to go through, whoops, we're going to try and go through -8, there we go, through -4, and then +1, and then boom, there's your graph. Okay, now to describe the end behaviors, you can see that as we move along this is the positive x-axis, right? So as we move along the positive x-axis towards positive infinity, what is the graph doing? Well, the graph is going up towards positive infinity as well, right? So as x approaches positive infinity, the function, the graph, right, f of x is also approaching positive infinity. Okay, now what about when we travel along the negative x direction, right, towards negative infinity? What is the graph doing? Well, the graph is going down, right? It's going down towards negative infinity. So here we would say, for this side of the graph, this other end, as x approaches negative infinity, the function f of x also approaches negative infinity. All right, so this would be our end behavior. All right, here's the next one. So f of x is equal to negative and then x plus 3 squared times x minus 1 times x minus 5. Okay, so how many solutions do we have here? How many zeros? Well, to make it clear, we can write this out. So x plus 3 squared is the same thing as x plus 3 times x plus 3, right? And then we still have these guys over here, the x minus 1 and x minus 5. And then let's just bring this negative sign down too, all right? So here you can see we have 4 sets of parentheses, so that means we have 4 solutions. So if we have 4 solutions, or in other words, an even number of solutions, we know our graph is going to look something like a parabola, right? So it's either going to look, something like that or something like that, all right? So what are our zeros or x-intercepts? Well, here you can see we'll have x is equal to -3. Same thing over here, right? Here we'll have x is equal to +1, and here x is equal to +5, right? So we have 3 points, right? So -3, 1, and 5. Okay, the other thing we can see here is we have a negative leading coefficient, right? Basically a -1 out here. So that means our parabola-ish graph is going to be facing down in this case, right? And the last thing I want to point out here is, as you saw, we have 2 of the exact same x-intercepts, right? So whenever you have 2 solutions that are the exact same, so in this case it's at -3, right? It's at this point right here. Whenever you have that happen, your graph doesn't go through this point, all right? So it's not going to go like that. It's going to just bounce off of that point like that. Okay, so if we draw our graph, we know it's going to be kind of like an upside down parabola. So this point, -3, again, we're not going to go through it. We're just going to touch it. So it's going to bounce off of it like that. Then we're going to go back up through 1 and back down through 5, right? So then those are our ends right there. Okay, great. So that's what our graph looks like. Now let's talk about the end behaviors. So as we move along the x-axis towards positive infinity, you can see that the graph is going down, right, towards negative infinity. So we'll say that as x approaches positive infinity, the function f of x approaches negative infinity. Okay, and then we can say the same thing on this side, right? So as x approaches negative infinity, the graph on this end is approaching negative infinity as well, right? So as x approaches negative infinity, the function f of x also approaches negative infinity. All right, last one, and this one's a bit of a tricky one. So this is f of x is equal to, in parentheses, x minus 4 times, in parentheses, 2x squared minus 2x plus 1, all right? Now, generally, when these problems are set up, you can just look at the number of parentheses you have, set what's inside equal to 0, and you can solve for your x's like that, right? So for example, x minus 4, here we can still say that we have a solution right here of x is equal to +4. Now, the problem with this set of parentheses over here, 2x squared minus 2x plus 1, is that this is not factorable. So we can't solve for x in this case, all right? So since we can't solve for x here, we only have one solution. We only have 1 0, and it's at x is equal to 4. So we'll just plot it here. All right. So in order to figure out the rest of the graph, you just have to plot some points. Some points that are somewhat close to +4. Some other x values close to +4. So if we make an xy table, some other numbers we can use are -1, 0, 1, 2, and let's just use 4 and 5. So to solve for y, and really this isn't y, right? I should write this as f of x. All you need to do is plug in your x values, right? So we'd plug in for the first one a -1 here, 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 right? And then solve for not y, but f of x. Okay, so instead of writing all those out, I think you could handle that. So I'll just plot the points or give you the answers basically. So if we plug in a -1, for f of x, we'll get 25. For 0, we would get -4. For 1, we would get -3. For 2, we would get -10. For 4, well, we already know what we get when we plug in a 4, right? We get 0. That's one of our zeros. And then lastly, for 5, we get 41. All right. So if you plot these points, so -1, 25, that would be like way down here. 0, -4, we'll say it's about there. 1, -3, 1, -3 is about there. 2, -10 is, that's actually going to be down here. 4, 0 we already have, and then 5, 41, right? So 5, 41 would be way up here. So then if we play connect the dots, you can see that it basically graphs somewhat of a cubic function, right? And to avoid some confusion, this 25 should have been a -25, right? So that's why I plotted the point down here at -1, -25, right? Now, the last thing we can do is talk about the end behavior, right? So here, as we move towards positive infinity on the x-axis, right? So as x approaches positive infinity, the function f of x, you can see, is also approaching, right? It's going up towards positive infinity. And as we move along negative infinity, or as x approaches negative infinity, we can see that the function is also going, well, it's going down in this case, right, towards negative infinity. So in this case, f of x approaches negative infinity. So if you found the video helpful, definitely leave a thumbs up down below. And if you have any other questions or want to see any other examples, just let me know in the comment section below.